Ashish Srivastava, a final year student from NIT Silchar. Today, I will be taking a topic on the JEE Mains syllabus, that is thermodynamics. Today, I will be teaching you what is first law of thermodynamics. The first law of thermodynamics states that energy cannot be created nor destroyed. It states that energy of an isolated system remains conserved, but it can change form from one form to another, which means we cannot create energy nor we can destroy energy. The law is del U equals to Q plus W, where del U is change in internal energy and Q is the surrounding heat. Whereas W is the work done. Now let's discuss total energy and internal energy. Total energy is the sum of kinetic energy, potential energy and internal energy, that is U. Internal energy is due to the atoms and molecules. Internal energy is the sum of transitional kinetic energy, rotational kinetic energy, vibrational kinetic energy, potential energy due to electrons and nucleus, potential energy due to force of attraction and bond energy. Practically, it is impossible to determine internal energy. That is why we determine change in internal energy. Why it is impossible to determine internal energy? Because as we see, internal energy is the sum of various components of energies. Practically, it is not feasible to find all the energies in an accurate manner. That is why we determine change in internal energy. Now, we will discuss the properties of internal energy. The first property of internal energy is it is an extensive property. The next property is it is a state function, which means when we plot a graph between pressure and volume, the internal energy depends on the final and initial point of the function. It does not depend on the path of the function. That is why it is a state function. And then internal energy is a cyclic process. In a cyclic process, the internal energy is zero because it does not depend on path. It depends on initial and final point of the system. Now, as we have seen, first law of thermodynamics is del U equals to Q plus W. We'll now calculate all the terms of law of thermodynamics, that is del U, Q and W. The calculation of del U, in del U is directly proportional to delta T. Del U equals to M CV delta T, where N is number of moles, CV is molar specific heat capacity at constant volume. The term delta T represents the change in temperature. We can calculate the specific heat capacity by the formula F by 2 into R, where F is degree of freedom. For monoatomic molecules, degree of freedom equals to 3. gases like argon, neon and helium. F equals to 5 for diatomic molecules, that is O2, N2 and others. F equals to 6 for polyatomic molecules like SO3. The value of R is 8.314 joule per mole Kelvin, and R also equals to 2 calorie per mole Kelvin. Now we will go through the calculation of heat, that is del Q. Heat is a form of energy exchange. Heat given to the system is positive, heat given to the system is taken as positive, and heat given by the system is taken as negative. Whereas the formula of heat equals to mc delta T for all the solids, liquids and gases, where m represents the mass, c represents the specific heat capacity, and delta T represents the change in temperature. And C can be of two types for ideal gases, that is CV and CP. CV is specific heat capacity at constant volume and CP is specific heat capacity at constant pressure. For ideal gases, we can calculate Q equals to NC delta T, where CV is same as F by 2 into R, where F is 3 for monoatomic gases, F is 5 for diatomic gases, and F equals to 6 for polyatomic gases. CP can be calculated by adding R to the formula of CV. By this method, we can calculate the del Q. Now, let me discuss the third term of the law, that is work done. Calculation of work done. Work done on the system is taken as positive and work done by the system is taken as negative. Work done can be calculated as minus P external into change in volume. For a variable system, when we have a graph of P into V, work done be calculated as area under the PV curve. Work done equals to area under the PV curve This is how we calculate all the three terms of the law of the thermodynamics. Now we will discuss some questions related to first law of thermodynamics. The question written here is of 2019 mains paper of 12th April. Here it is written, an ideal gas is allowed to expand from 1 liter to 10 liter against a constant external pressure of 1 bar. The work done in kilojoule is. Here the question is talking about an ideal gas. It is allowed to expand from 1 liter to 10 liter and against a constant external pressure. So just now we read about work done, which is equal to work done equals to minus P external into delta V. This formula is valid when the pressure is constant, and in this question we have a constant external pressure, so we can use this formula. So here P equals to 1 bar, that is minus 1. The volume expands from 1 liter to 10 liter, so that is 10 liter minus 1 liter, which is equal to minus 9 liter bar. But as you can see above, the question asks the answers in kilojoule. So we will try to convert the unit. We know 1 liter bar equals to 100 joule. So here minus 9 liter bar equals to minus 0.9 kilojoule, which tells the answer to be C. Now, let us discuss one of the simplest questions asked in JEE Mains, that is, during compression of a spring, the work done is 10 kilojoule. change in internal energy is, here we are talking about compression of a spring where work done is 10 kilojoule and the heat escaped is 2 kilojoule. So work done is done by us, which will be taken as positive. And the heat is escaped to the surrounding, which means heat is released to the surrounding. So that will be taken as negative, that is minus 2 kilojoule. As we know, first law of thermodynamics states that del U equals to Q plus W, and here we get the Q and W. Q is minus 2 and the work done is plus 10 kilojoule. So we can directly calculate the change in internal energy, that is 8 kilojoule. Now we'll take one more question, that is 0.5 mole of O2 is heated from 25 degrees Celsius to 125 degrees Celsius at constant pressure. Calculate Q, del U, W, where Cp is given to be 7 calories mole Kelvin. Okay. The formula for Q is NCP delta T, where N is 0.5 mole, Cp is 7 calories, and delta T is 125 degrees Celsius minus 25 degrees Celsius. That is 0.5 into 7 into 100, which is 350. Now we'll calculate del U. Del U equals to NCV delta T. To calculate del U, we need to calculate CV. CV equals to F by 2 into R. F, where F is degree of freedom. For polyatomic molecule, F equals to 5. So 5 by 2 into R. CV equals to 2.5 into 2, because R equals to 2 calorie mole Kelvin, which is equals to 5 calorie per mole Kelvin. Therefore, value equals to 0.5 mole, CV that is 5 and delta T is that is 100, which is equals to 250. Now we will calculate work done. So, as per the first law of thermodynamics, we know that del U equals to Q plus W. We have calculated del U and Q, so that we can calculate W. So del U is 250, Q is 350. Therefore, work done equals to minus 100. So by this way, we conclude our first law of thermodynamics. In this lecture, we have seen what first law of thermodynamics is, how we can calculate all the three terms of first law of thermodynamics, that is Q, del U and W. Thank you.